Screen is visible to all. Hello. Screen is visible to all. Can anyone confirm?
Yes, sir.
So this question I have already discussed in first session. Already this question is asked in 2023 electrical engineering. So here what they have asked what will be the average output voltage. But in this session I will analyze what will be the all the parameter of the source current. This is the shape of the source current already we have drawn in the previous class. So for this source current, I will analyze all these things. What will be the RMS value of this source current? What will be the average value of this source current? And what will be the fundamental RMS value of the source current? Same thing I will show in simulation waveform also. So first we'll go step by step. What is the magnitude of this source current? Can anyone tell? What will be this amplitude, this value? As per load current, it should be 10. Since load current is constant 10 ampere, so this here it will be 10 and below it will be minus 10. This is the one time period for this source current waveform. This is 2 pi. Anyone have doubt in the source current waveform? They can ask. Already I have discussed in last class. Should I proceed or anyone have doubt in the source current waveform? Okay. Hmm. So how we can calculate the RMS value? RMS value will be ISRMS magnitude is 10. So 10 into up to what time it is conducting in 2 pi. 2 pi if we'll see here pi plus alpha to 2 pi. So what will be the in 2 pi only for pi duration alpha duration it is not conducting. This is the alpha duration. Alpha is how much? 60 degree. This is already given. This is 60 degree. So we can see that in duration of 2 pi, this is not conducting only for duration of 60 degree. So what will be the RMS value? RMS will be 10 into 360 minus 60 divided by 360. What will be this value? Can anyone tell? ISRMS. This is the RMS value of the source current. Can anyone calculate? So this will be 10 into 300 by 360. Already we have calculated this in last class. So this value will be 9.12 ampere. 9.12 ampere. Okay. So this value we have calculated. ISRMS. What will be the average value? Can anyone calculate? I will give you 1 minute of time. You can calculate and tell the answer in chat box. What will be the average value of this source current? We see the source current. Everyone is getting the RMS value correct?
Getting, sir.
Okay, okay.
RMS,
So,
ISRMS, getting.
okay, okay. So you can calculate the average value also. What will be there? Since here positive area is not equal to negative area, it is visible from this waveform. So some average value will be there. Can anyone tell what average value will be positive or negative? Directly visible from this waveform, it will be positive or negative. Period from here to here. Which area is more in this waveform? 0 to 2 pi?
So the average value, it is symmetrical wave, sir.
Not see here it is 0. See 0 to 2 pi. This is one period of the waveform. Here we can see that neither it is positive nor negative. Okay. Here positive, here negative, and here negative. So overall area will be, total area will be negative only. What is the average formula? 1 by T into area for one cycle. This one will be, so what will be the area? Can anyone tell? Can anyone calculate this one? IS average. Anyone have calculated this value? I will wait for 1 more minute. You can calculate this one. This is the average value of the source current. What is the time period? 1 by divided by 2 pi.
1 by 2 pi time period.
1 by 2 pi into this all area under this waveform. So here what will be the area? Here this is 0 to alpha. So this is minus 10 into alpha.
Minus 10
This
into
similarly here to here this is pi minus alpha. So plus pi minus alpha into plus 10. Similarly here to here this is pi plus alpha to 2 pi. So it will be 2 pi minus pi plus alpha. It will be pi 2 pi minus pi. So pi minus alpha into minus 10. So finally, if we'll calculate this one, you will get this pi minus alpha into minus 10. This will be cancelled, plus and minus. Okay, so it will be minus 10 alpha divided by 2 pi. Okay, so final average value will be, if we'll calculate this one, alpha is how much? Pi by alpha is how much? Pi by 3.
60 degrees alpha.
Okay, so it will be minus 10 upon 6. It will be somewhere minus 1.66. So this will be the average value of the source current. Here we can see that this is the positive area in one cycle and these two are the negative area. So this negative area is more than positive area. So average will be negative only. So we are getting minus 1.66. Is it clear?
Clear, sir. Clear.
Okay. So now I'm going to explain the like source fundamental value. See, in normal whatever till now asked in gate, that will be either full bridge or semi converter. But this circuit is neither full bridge nor semi converter. Okay. So normal formula will not work here. We have to go with basic Fourier analysis. So this waveform we have to calculate AN, BN and A0 with Fourier formula. Then we can calculate this RMS value. Okay. So one by one I am going. See what will be the A0 value? Can anyone tell? This is one waveform. For this we have to, what is the Fourier series formula? Fourier is A0 plus sigma n is equal to 1 to infinity n cos n omega t plus bn sin n omega t. Can anyone tell what will be the value of this A0 here? Already we have calculated. A0 means average value. A0 is 1 by t into ft dt. Okay. Value of A1, An we can calculate. So An will be, An is equal to 2 upon t, 0 to t, f of t cos n omega t dt. This only n value. What will be the Bn? Bn is equal to 2 by t, 0 to t, ft sin n omega t dt. So what is the period here? Period is 2 pi. Period is 2 pi. So omega we can write as omega is equal to 2 pi by time period is already 2 pi. So 2 pi by t, 2 pi by 2 pi is equal to 1. Okay. So now we can write the equation. An is equal to 2 upon 2 pi. This amplitude I am taking as I naught and this is as minus I naught. Okay. So it will be 0 to alpha. What is this ft value here? Minus I naught. So minus I naught. Omega value already we got as 1. Minus I naught cos nt dt plus here alpha to pi here I naught. So I naught into cos nt dt. Further here pi plus alpha to 2 pi. So we have period up to 2 pi only. What will be the value? Minus I naught cos nt dt. Okay. So this we can write as I naught upon n pi. This every integral if we'll do, n will be going division. So sign differentiation already caused. So what will be here? Minus sine nt 0 to alpha. And this will be, what it will be? Sine nt. Sine nt alpha to pi plus minus sine nt pi plus alpha to 2 pi. After further if we'll simplify, we can write as, this is minus sine alpha minus 0. So with this we can write as I naught upon n pi minus sine n alpha. This will be sine n pi. So what will be the value of sine n pi for all value of sine n pi? What will be the value? It will be always 0. Either n will be 1 or 2. So this we can write as 0. Further it will be minus sine n alpha. What will be this value? Minus sine 2n pi minus plus sine 2n sine n pi plus sine n pi plus n alpha. Can anyone tell what will be this value for odd harmonics 135? What will be the final expression? Can anyone simplify this one? See, this is 2n pi. It will be for n is equal to 1. What will be this value? This will be 0 for all value of n. Am I audible? Hello?
Yes, sir.
Okay. Can anyone tell the final value? This is one sine minus sine n alpha. Another one is minus sine 2n pi value. What it will be? It will also be 0 for all value of n. See, sine 2 pi or sine 4 pi, everything will be 0 only. So this also we can omit. So what will be the final value? Final value will be we can write as, one second. An is equal to I naught upon n pi. So here two are there, minus sine alpha minus sine n pi. So we can write as minus 2 sine n alpha. What is the third value? Sine n pi plus n alpha. This is plus or minus? This is plus. Plus sine n pi plus n alpha. Okay. So what will be the value if n is equal to 135? This will be negative. Sine pi plus alpha. So here pi plus alpha, it will go in third quadrant. So what will be the value? Minus sine alpha, minus sine n alpha. So n is equal to 135. We can write as I naught upon n pi. This will be minus 3 sine n alpha. Is it clear up to now? 12. This is the value of the n for only odd harmonics. Even harmonics also it will be there. So even 2 pi. So 2 pi plus alpha, it will become here. So that will be positive. So for n is equal to 135, this will be the value. Other harmonics, what will be the value? That will be I naught upon n pi. This will be plus. So it will be minus sine n alpha. N is equal to 246. Is it clear up to now to all? Hello? Can anyone reply?
Sir, I came halfway the sum, so not really sure what what's going on.
Okay, okay. One by one, I will explain again. So, those who came late for them. So, this is the question in which we have to calculate source RMS current, average current. So, RMS current, the value will be already I have explained. This is the simple formula. So, for what angle it will conduct that. So, here we can see that this is the source current here in this rectifier circuit. This is the waveform of the source current. So this is present only for the in 2 pi duration. It is present only for the duration 360 minus 60. So it will be 300 degree. Okay. So how we can calculate the RMS value of the source current? It will be magnitude of this value. So 10 into 360 minus 60. This 60 it is not conducting. So 360 minus 60 divided by 360. So this will be the RMS value of the source current here. Okay. Further, average value of the source current we can calculate like this, 1 by T into area. So area for this curve I have calculated like this, minus here this area minus 10 into alpha, this one second, this one minus 10 into alpha. Further this one pi minus alpha into 10, and this area from here to here, this is also pi minus alpha into minus 10. So this two will be cancelled. Here these two will be cancelled. So average value will be minus 10 alpha upon 2 pi, which will be minus 10 upon 6 minus 1.66. Okay. Further, what I am calculating, what will be the fundamental RMS component. So this is a square kind of waveform. So this we can do the Fourier analysis and we can calculate this fundamental source current. Okay. So for that I am doing the Fourier analysis, and here these are the Fourier analysis formula we can apply. So A0 is average value, which already we have calculated, that will be minus 1.66. This is N formula and Bn formula. So here this is the time period 0 to 2 pi. I am calculating the An. So An will be 2 upon 2 pi. First will be 0 to alpha. 0 to alpha it will be minus I naught cos nt. Omega value we are calculating here. So omega is equal to 2 pi upon t. Time period is 2 pi. So omega value will be 1. Okay. So n omega t will be nt here. Directly here omega value will be 1. So it will be nt. So 0 to alpha minus I naught cos nt dt plus alpha to pi I naught cos nt dt. Here it will be minus I naught again. So pi plus alpha to 2 pi minus I naught cos nt dt. So after integrating this, we'll get this I naught upon n pi. This expression will come. Further, by simplifying this one, we are getting I naught upon n pi minus 2 sin n alpha plus sin n pi plus n alpha. So for odd harmonic, what will be this value? This will be minus. You see, this is going in sin 180 degree plus alpha, means it is going in third quadrant every time. So third quadrant value will be negative. This is the formula, like we can remember all, here sine, here tan, and here cos. This will be positive. Okay. So if it will here it will, we are doing 2 4. 2 4 means it will come in first quadrant. That time it will be positive, and here when it is coming, when it will be negative. So it will be negative for odd harmonic, this part, and positive for 2 4 6. So negative means minus 2 and minus 1. So n will be I naught upon n pi minus 3 sin n alpha for n is equal to 135. Okay. And it will be I naught upon n pi minus sin n alpha for 246. Is it clear to all till now?
Yes, sir.
Okay. So further we can calculate the value of the Bn. Okay. So Bn, similarly we can calculate Bn is equal to 2 upon T. Okay. What is the waveform? Okay. Alpha to 0 to alpha. Same in place of cos we have to keep the sign. Okay. So 0 to alpha minus I naught sin nt dt plus alpha to pi sin nt, I naught here also will be there, I naught sin nt dt plus next will be pi plus alpha to 2 pi. So pi plus alpha to 2 pi, it will be minus I naught pi plus alpha to 2 pi minus I naught, one second, minus I naught sin nt dt. Okay. So it will be I naught upon n pi, and will be common denominator. So this will be minus cos nt, minus cos nt, or it will be cos nt. Can anyone tell? Here it is coming minus, so here it will be cos differentiation is minus sign, so it will be plus only cos nt 0 to alpha plus, here it is plus, so it will be minus cos nt alpha to pi plus here cos nt pi plus alpha to 2 pi. Okay. Further we can simplify this. It will be I naught upon n pi, cos 0 will be always 1, so cos n alpha, what will be the value here? It will be minus, so cos alpha minus 1. Okay. This will be cos n pi. So minus cos n pi plus cos n alpha. Okay, and this will be plus cos 2n pi minus cos n pi plus n alpha. It is not visible. One second. Is it visual? That last line to all, or should I write it again?
Can you write it again, sir?
Okay, wait, I will write. So next page. So it will be I naught upon n pi cos n alpha. First one is cos n alpha, then it is minus 1. Okay, then what is the second term? This is minus cos n pi. Okay, so minus cos n pi plus cos n alpha. One second. Minus cos n pi plus cos n alpha. Okay, what will be the next term? Cos 2n pi, I think cos 2n pi plus cos 2n pi minus cos 2n pi cos n pi plus n alpha minus cos n pi plus n alpha. So here we will do it for odd harmonics. What will be the value? So 2n pi, what will be the value? Cos 2n pi, can anyone tell? For every value of n, cos 0 will be 1 only. It will come at 0 axis always here. So cos 0 is 1. So this 1 minus 1 will be cancelled out. Right? So I naught upon n pi is first term cos n alpha. Cos n alpha. This is minus cos n pi plus cos n alpha. This last term minus cos n pi plus n alpha. Up to now, is it clear to all? Or I
Yes, sir.
can, okay. So for n is equal to 135, what will be the value? See, this will be, pi will be what? It will be negative. So it will be plus 1. Okay. What will be this value? Cos n pi plus n alpha? It will be minus. So minus minus will be plus. Okay. So Bn will be I naught upon n pi. Okay. 3 cos n alpha plus 1. For n is equal to 135. So we have to calculate the fundamental only. So we'll stick to this equation only. This is Bn equation for n is equal to 135 and An equation, this is the An equation for n is equal to 135. So with these two equations, we can calculate the fundamental component. Is it clear to all up to now?
Yes, sir.
Okay. So what will be the value of the amplitude of the fundamental component? So Cn we can write as Cn is equal to under root an square plus bn square. Okay, a standard Fourier series term we can write like this: a naught plus sigma n is equal to 1 to infinity Cn sine n omega t plus phi n. Okay, so this is the amplitude of the amplitude of the Fourier series. So at n is equal to 1, we will get the fundamental value of this one. So Cn will be under root n square plus bn square. So that we can write as, so what is the value of n? N is equal to I naught by n pi minus sin n alpha. So n is equal to I naught by n pi minus sin n alpha. Minus sin n alpha. Is it clear? Or something wrong is there? One second. It is, one second. Minus 3 sin n alpha. For this one, it will minus 3 sin alpha. So we are calculating for fundamental. Okay. So this we will consider. So minus 3 sin n alpha, an. What is the bn? Bn is equal to I naught upon n pi, 3 cos n alpha plus 1. I naught upon n pi into 3 cos n alpha plus 1. So we can do n square plus bn square. So what it will be? I naught upon n pi whole square. Okay. So here it will be, I'm taking it as common. So 3a square sin a square n alpha plus 3a square cos a square n alpha. Okay. Plus 2 into 3, 6 cos n alpha. So Cn will be a square root of this. Is these equations are correct? Can anyone tell these calculations are correct or not? So I naught by n pi we can take outside, I naught upon n pi. This will be 3 into 3a square will be 9. I think we are missing at 1. Here 1 will be there. Okay. So a square plus b square will be 1 only here. Okay. So plus 1 will be there also. Plus 1. Now it is clear. So this will be a plus b whole square. So a square will be 3a square cos a square n alpha. B square will be 1 square 1. 2ab means 2 into 3 into cos n alpha. So 6 cos n alpha. These are a square of this one. And this is a square of, I am putting here. So 3 square sin a square n alpha. So it will be 9. It will be under root here. 9 plus 1 plus 6 cos n alpha. Can anyone calculate what will be the final value of the Cn? So Cn is the peak value of the fundamental source current. Cn will be the, if we will put n is equal to 1, so that will be the peak value of the fundamental source current. So this equation is valid only for n is equal to 1, 3, 5 and so on. So I am calculating for n is equal to 1. So it will be 10 upon pi into 9 plus 1 plus 6 cos alpha. What is the value of alpha? Cos 60. Okay. So it will be 10 upon pi into 9 plus 1, 10. 10 plus this 6 by 2, 3. Can anyone calculate what will be this value? And reply in the chat box. What will be this value? So this will be the amplitude of the source current and the IS1. IS1 amplitude is equal to 10 into root 13 divided by pi. Can anyone reply? What will be the answer?
11.47.
Okay, so amplitude we are getting as 11.47. This is the amplitude of the source current. Okay, up to now everyone got the clarity up to here. So same thing I will show with the simulation. Okay, same circuit I have simulated. So I will show you once again. See the same circuit I have simulated here. So is it visible to all?
Yes, sir.
Okay.
Sir, which
So
software is this? MATLAB?
not MATLAB, it is a Plex software. It's not a free software. If you are studying in some IIT or NIT, then there you will get the free license for this one, Plex software. Otherwise, maybe some cracks versions are available, but that
Sir,
is
when
not.
we'll crack IIT, NIT, then we'll do this, sir.
Okay, okay. MATLAB also you can do, no? Like LTS Spice also one software is there. That is a free software, LTS Spice. In LTS Spice also same thing you can do. There also you can realize any converter. Okay. Since I'm using this software, so I'm using in this one. So LTS Spice also, all of you can download the LTS Spice. So basic network or any circuit if you are doing, anywhere you are facing the challenges, you can realize circuit in Simulink and you can check there. So
Sir,
see here.
from mobile softwares are also there, sir.
Okay, mobile also you can do the simulation, like you can draw any circuit and you can check the waveform. So see, this is the source current I'm getting. This green color is the source current, and this red color I am extracting the fundamental from that source current. So FFT I'm applying here. See where you can see that FFT block is there. What it will do, it will draw the fundamental component. Here I have selected 50 Hertz frequency and I am drawing the fundamental component. So here we can check the amplitude, whatever we have calculated. So this red color is the fundamental current. Okay. Here you can see that, like, 1 second. This is the 10 axis you are seeing. So it is more than 10 only. So 11. 1 second. I will show. I will take it and show. 1 second. So n axis we can show, no? Here it is 11 only. 1 second, I will show the amplitude here. So here what we are getting, I have connected here also. So amplitude we can see here how much we are getting, 11.4 or something like that. Okay, how much this is? 11.476. This much only we have calculated.
Yes, sir.
So this is the final answer. So if this type of question will be asked in exam, just you have to calculate an and bn. This is simple step, not like if this type of question can be asked in 2 marks. Okay, just you calculate a1 and b1, and then you can get this amplitude, and what will be the final RMS value? So RMS value will be this divided by root 2. IS1 RMS will be IS1 RMS. This will be divided by root 2. So 11.47 divided by root 2. What will be this value? Can anyone tell? It will be somewhat 8 point something. Okay, 8 point.
8.116.
Yes, sir.
Okay, so this will be the RMS value. Okay, what will be the angle? So for this kind of like if we are calculating, so how much angle it is leading, the source current is lagging the main fundamental voltage source. Okay, so here we can check that. You can see here. See, this is what I have calculated. It is up to 20 degree. It is here we can see. This is red color is the source current, and this is the source voltage. So here we can see that up to 90 or something angle is coming. 90 degree it is lagging the fundamental voltage. So source current is lagging the voltage by 90 degree. So how we can calculate that here? So that will be 1 second. Here already have this formula I have written. So phi value we can calculate as phi is equal to, in this formula, phi is equal to tan inverse. I think already all of you know, those who have studied the signal. So it will be tan inverse an upon bn. Okay. Can anyone calculate this value? How much? An is this one, I naught upon n pi minus 3 sin n alpha. Bn is equal to I naught upon n pi 3 cos n alpha plus 1. So I naught upon n pi, it will be cancelled. So phi will be tan inverse here minus sin n alpha, minus 3 sin n alpha divided by minus 3 sin n alpha divided by 3 cos n alpha plus 1. Can anyone tell how much is this value? N is equal to 1 you have to take. So it will come more 1 minus 3 into, it will come somewhat 120 or something like that. Minus 3 into sine 60 divided by 3 cos 60 plus 1. How much? Minus 46 or something like that. Anyone getting? Hello? This formula only we have to, this an divided by bn, tan inverse. So 3 into sine 60 minus 3 into sine 60 divided by 3 cos 60 plus 1. It will be minus 46 or something. Anyone getting the answer? Hello? All of you have calculator, like you should sit with gate calculator whenever you are joining the session. So better to install the gate calculator in the your laptop. Then you can always you have to practice with that only.
I'm getting minus 45
Okay,
points.
it will be minus 46 or something. Okay, so this much lagging we are getting in the current. This is the source voltage. Okay, so fundamental source current will start from somewhat here. Okay, like this is 50% of this only we have observed in the waveform, that there I have not calculated. So amplitude, how much we got? 11.47, and this phase lag of the component, how much? Minus 46. Okay, minus 46 degree. So from here we can calculate the all the parameters. What will be the distortion factor? Can anyone calculate? Distortion factor is current distortion factor. Okay, so it will be IS1 by IS, CDF. IS1 by IS, what it will the value? IS1 we have already calculated RMS, how much? 8.11, and what was the RMS value? 9.12. So this will be the current distortion factor, CDF. And what will be the displacement factor? Displacement factor will be cos 46. And from here we can calculate the input power factor. Input power factor will be CDF into DF. Can anyone calculate these values? You can write in the chat box. I will wait for some time. Okay, 0.889. Which value? This CDF. Okay, I am also
Yes, sir.
calculate 8.11 divided by 9.12. It will be 0.889. So first will be 0.889. Second will be cos 46. One second. One second. Second will be cos 46. So cos 46, how much we are getting? 0.694. Okay.
Yes, sir.
So this will be 0.694, and this input power factor will be multiplication of these two. So 0.694 into 0.889. So what will be the input power factor? 0.617. Okay, this will be the input power factor. TSD formula also we can write. So TSD is equal to 1 upon DF whole square minus 1. Okay. So distortion factor already we have calculated. So it will be current distortion on upon 0.889 whole square minus 1. 1 upon 0.889 whole square minus 1. So this will be 51.5%. Clear? So this is all. If anyone have doubt up to in this question explanation, then they can ask. I will repeat again. In this question, only gate have asked what will be the output voltage. This type of question also they can frame. Like what will be the RMS value of the source current, or what will be the fundamental value of the source current. Okay. And you have to be careful. Sometimes they are asking amplitude. Okay. If they will ask what will be the amplitude of the source current. Amplitude will means the peak value. This one. If it will be asking what will be the amplitude of the fundamental value of the source current, so that will be the 11.47. And if it will be asked what will be the RMS value of the source current, so that will be 8.11 amps. Anyone have doubt in this question? Otherwise, we can move to the next question.
So this question belongs to which topic, sir?
Power electronics.
No, sir. That is the subject.
Rectifier. Rectifier.
Rectifier.
So this is a rectifier circuit. Okay, different kind of rectifier topologies are there. In that, like full bridge rectifier means all four will be thyristor. If all will be diode, that will be called as uncontrolled diode bridge rectifier.
Sir, can you please explain a brief introduction about thyristor?
Thyristor, okay. So thyristor are the switches. See, this is the switch. I can tell you with respect to power electronics. So whenever
Yes.
giving pulses here, it will start conducting. This is a semi-controlled switch. Okay. Semi-controlled means this is the gate of the thyristor. Okay. Whenever we are giving the input current, gate current, then it will start conducting. Okay. But turn off, we don't have any control. It will turn off at 0 instant. So see, this is the input voltage, sine voltage. Okay. So if here we are giving the pulses, automatically it will turn off at zero crossing. Okay. So these are the semi-control switches which we can control, like turn on we can do, but turn off it will do at naturally. Otherwise, some commutation circuits are required for post turn on. Okay.
So we believing in the fact that T1 is getting some signal, sir.
Yes,
That's
T1.
why it is on.
Yes, yes. No, no. Instant we are pulse we are giving. See, I will show you. 1 second. This is the thyristor. Okay. Some latching current and holding current will be there. So this is the gate current. Okay. So across this we are applying some pulse, some gate firing circuit will be there. So across gate we are applying some pulses, a small duration pulses. So if this pulse will be there, okay, so this current will reach to some value, this anode current. If it will be greater than some value, then it will be uh, turned on. Okay, if you will remove this pulse also, it will be turned on only. So we are applying the pulse for some duration such that this current will reach a particular value. Some latching current value will be there. Let's say if the device has 5 ampere of latching current. Okay, so we'll apply the gate pulse for that duration such that if it will reach 5 ampere, then if you remove the gate pulse also, it will be in turn on condition only. Is it clear?
Okay, sir.
Okay. We are not applying constant signal. We are applying just a pulse. The pulse duration will be such that it will reach the latching current. Okay. Anyone have other doubt in this question? Should we move to the next question?
Yes, sir.
Okay. Okay. So this question is also asked in 2023 GATE only. It is looking difficult question, but I will try to solve with easier method. Okay. So many people will do with many method, like someone will calculate the Thevenin's voltage across this. Okay. Someone will calculate here Thevenin's all solution. If you will see whatever coaching they gave, here they will do the VTH and RTH. That will be a lengthy method. So what I will show you, that will be a shortcut method. With that we can solve this question within 2 to 3 minutes. First you have to just write the equation of this one. So what is the Y parameter equation? Y parameter is equal to I1 is equal to Y11 V1 plus Y12 V2, and Y2 I2 is equal to Y21 V1 plus Y22 V2. Okay. So this I am going to represent like a network. So this we can show as like this one. So this is one impedance branch, and this is one dependent current source. So this is I1, this is Y11, and this is Y12 V2. Okay. Again, this side we can write as this is one current controlled current source, and here it will be this is Y22, and here it will be I2. So I2 is equal to Y22 V2, and what will be this one? What will be this value? This value will be Y21 V1. Is it okay? Is it clear?
Yes, sir.
Okay. So same circuit we can write as 1 second. So same circuit. Y means what we are saying Y means admittance. Okay. So this is V1 voltage. I will explain how I have drawn this circuit. Say, let's say this is V1 voltage. This is V2 voltage. Okay. So here what will be the current? Current is equal to voltage into admittance. Okay. So this will be Y11 into V1. This current will be there. And this is already I have written Y1 to V2. So this equation is satisfying this side. This is port 1 of the network. This is the port 2 of the network. Y21 V1, and 1 second. This is what is this value? Y12. So Y21 V1 plus this is Y22. So Y22 into V2 will be this current. So at this node, this equation is satisfying. So this is the two-port network. From this equation, we can represent like this. Okay. So as per value we can put here, we can draw this network like what is Y11? Y11 is 5. So this is, you have to remember, this is not admittance, this is impedance. Not impedance, this is admittance. Okay. So this is 5. Y11 is 5. Okay. Further, what is here? This source Y12. Y12 is equal to Y21 minus 2.5. So minus 2.5 V2. Okay. This will be connected here. Further here, this will be minus 2.5 V1. It will be connected here. And here, what will be the value? This will be 1. So this 1 is not admittance, not impedance, it is admittance. So what will be the R for this one? R is equal to 1 by Y, same only. Same only. Okay. So we are writing here, but if we are doing any KVL KCL conversion, there we have to like careful, we have to convert into the resistance. Okay. So now I'm going to draw the whole circuit together. First I will copy this one. 1 second. So this is the part of the circuit. So whole circuit I'm going to draw. Initial what is there? 20 volt is there. So 20 volt. 20 volt voltage is there. After that, this two ports network is connected. That is connected to ground. So we can write like this one. This all are connected to ground. Okay. And this is 5. So impedance will be 1 by 5. Okay. This is minus 2.5 V2. And here one voltage source, current source will be there, minus 2.5 V1. Okay. And here 1 will be there. Just after drawing the circuit, in one step we can solve it. Okay. So up to now it will be like this. At top, one 3 ohm resistor. This is port 1 and this is port 2. On top, what is there? One 3 ohm resistance is there, 3 ohm. Okay. And below it is connected here at load. What is there? Here 6 ohm resistance is there at port 2. Here from here to ground, a 6 ohm resistance is connected. So here we can connect a 6 ohm resistance. Okay, this is port 1, this is port 2. This I am taking as ground. So up to now I have drawn the complete circuit. Now I will do the calculation. Anyone have doubt till now in this circuit? Here only we have to calculate the power absorbed by this 6 ohm resistor. Is it clear to all?
Yes, sir.
Yes, sir.
Okay. So at this node we can apply the nodal analysis here. At node 2, this node, I am going to apply the nodal analysis. Okay, I will explain the diagram again. See, this is the two-port network equation for Y parameter for this branch, resistive branch only. Okay, I1 is equal to Y11 V1 plus Y12 V2. Similarly, I2 is equal to Y21 V1 plus Y22 V2. So same this equation we can draw a two-port network like this. So this equation I am converting into this network. Here we can see that this is I1, okay, and this is Y11. So Y is admittance. Admittance into voltage. What will be the current in this branch and current in this branch? So here what I have written here, Y12 V2, and this is Y11. So what will be the current here? Current is equal to voltage into admittance. Okay. So this current will be Y11 into V1 and this current will be Y12 into V2. So this equation is satisfying here. This first equation, this is port 1. Okay. What is the port 2 equation? I2 is equal to Y21 V1 plus Y22 V2. So this voltage is V2 here at port 2. So Y22 into V2 will be this current. Okay. And this current already I have written here, this one Y21 V1. So at nodal, if you'll see here, I2 is equal to Y22 V2 plus Y21 V1. So this equation is also satisfying here. So this two-port Y parameter network I have converted into this model. So any two-port equation, you can first draw this kind of network and you can connect in the circuit. After then you can do any KVL case analysis. Up to now it is clear from this equation to this circuit. Everyone got clarity? Is
Yes,
it clear?
sir.
Okay. So same circuit I have written here, all the value I have kept. Okay. So this is admittance 5. This admittance 5 I11 I have placed here. This is I1. This is I2. Here also y or r or y it will be same only here since it is 1. So 1 divided by 1 will be same only. But if it will be some different value, you have to, if you are doing KVL KCL, you have to see that. Okay. So this is minus 2.5 V1. Already y21 is equal to y12 is equal to minus 2.5. So here y minus 2.5 b1, here minus 2.5 b2. So this part, this is 0.1, okay, and this is ground. Ground of this two-port network is connected here. Here 1 and 2 dash both are connected here. This is 1, this is 1, this is 1 dash, this is 2, this is 2 dash. Okay, so this network 1 is connected here, 1 dash is connected here, 2 is connected here, 2 dash is connected here. So this circuit I am doing connection here. This is 1, this is 1 dash. Okay. At top one resistance is there, 3 ohm resistance. This one. 5 ohm or 3 ohm? This is 3 ohm. Is it 3 ohm only?
Yes, sir.
So here it will be 3 ohm. This is 3 ohm. And 3 ohm resistor is there. And this is 1, this is 1 dash. This is 2, this is 2 dash. And here one 6 ohm load is there. Is it clear? This circuit?
Yes, sir.
So this is 1 ohm. 1 ohm or 1 S week, anything will be same because 1 divided by 1 will be same only. So this I am taking as ground. Now is this circuit is clear to all?
Yes, sir.
Okay. Now in one step we can get the final answer. Up to now only you have to do the analysis. See, at point 2 I am writing the KCL equation here. So what will be the this V1 voltage? V1 is the voltage of this point with respect to ground. So V1 we can write as V1 is equal to 20 volt. Is it clear? V1, this node 1 voltage. So from
Yes,
ground to here is 20
yes,
volt.
yes, sir.
So what will be this current? Minus 2.5 into V1, it will be minus 50.
Minus 50.
Minus 50 ampere it is following below in this circuit. Okay. So I'm going to write the KVL. This voltage I am selecting as V2. So I'll write V2 minus 20, this branch current, divided by
Divided by 3.
3
3.
plus this is minus 50
50. Yes.
plus
Yes.
this is V2 divided by 1 or V2 into 1 plus V2 plus here V2 by 6 is equal to 0. Here V2 by 6, here V2 by 1. Is it clear? So finally we can common V2 1 by 3 plus here 1 plus 1 by 6 is equal to, this is 20 by 3 plus 50. So 50 into 3, 150 plus 20, 170 by 3. Can anyone calculate the value of this voltage? What will be the value of this V2? So 1 by, so 3, 6 LCM will be 6 only. 3 into 2, 2 plus 6 plus 1. 2 plus 6 plus 1. This one, V2 into 2 plus 6 plus 1 is equal to 170 by 3. Can anyone calculate the final value? I'm also calculating. So
85, sir.
final how much?
85, sir.
Okay, let me calculate also. 170 into, 1 second. 6 plus 2 plus 1, 9. So 170 into 6 divided by 9 into 3. 37.37 it is coming, something like that. Anyone is getting? See, V2 is equal to 170 into 6 divided by 3 into this 6 plus 2 plus 1, 9. It will be 37.7.
37.8, sir, almost.
37.77. So what will be the power here? Power is will be V square by R. V
Yes.
square by R. This is the answer. Power is equal to V square by R. What is the V value? 37.77 whole square divided by this R value 6. So 37.77 whole square divided by 6.
Hello, sir.
Yes.
in the second part of the graph, in the second right side, the control the
Okay.
voltage control it is minus 2.5 into V2.
Okay. 2 - 2.5 here, minus 2.5 into V2. Okay.
It is
This one,
minus 2.5 into V1, and the right side minus 2.
this is V2 and this is V1. Okay. This side it will be V2, this side it will be V1. Already I have told now, this I1 is equal to Y11 V1 plus Y12 V2. Okay. So here it will be Y12 V2 and this side it will be Y21 V1. Is it clear?
Yes, sir. Yes, sir.
So here it will be V1, here it will be V2. So this side of circuit no need to see. Here only we are collecting data V1. Okay. This data only we are collecting and we are applying KCL at this node. And finally we are getting the final answer. Final answer how much? 237.76. So it will be 237.76 watt. Is it clear?
Yes, sir.
Yes, sir.
See, this type of method you can apply any two-port. I will suggest you all any two-port network question. Either it will be a maximum power transfer theorem or any question. If you will go by this way, confusion will not be there, and you can get the answer easily in one step.
Sir, this process is very easy, sir. Where did you find this?
Actually, while preparation, I have developed this method. Like while analyzing, I have done the preparation long
Because
time.
sir, while I was doing this question, I converted this Y to Z, and then again I converted to like T, you know, sir, that T
Okay.
resistance.
Yes,
Yeah,
yes,
in
so
that
many
way.
methods are there. So see, I have done too much of practice. So with practice, I got this kind of idea. Okay, how to do the question in shortcut method.
Sir, it is your own method, sir.
Yes, I only have developed. Nowhere you can find this type of analysis in
I didn't find this subject solution anywhere.
any coaching material. You will not find this kind of analysis. Whatever with my personal analysis I have observed. So in this session, I will do all those things. What tricks I got during the analysis, everything I will try to deliver. Okay, like some shortcut methods are there in every sub, like power electronics or network or machines also. If I have some shortcut tricks, I will try to deliver those concepts during this session. Either it will be not a gate question also. If I have some good conceptual question, that also I will discuss here. Okay. So I think 3-4 minutes are remaining. Any other doubts you can ask? Otherwise, if you will take any question, it will take more minutes. So next session we can do.
Sir, what is the program for the next session?
Next session I will come up with some power electronics only, like most probably DC to DC converter. Some power electronics question I will take.
Buck boost converter, that all that.
Okay. Yes. That kind of question. I will
So
do
that is
some.
very important, I think, sir. That buck boost.
Okay. I will do some new thing in that also. So whatever I'm doing here, I will try to explain with MATLAB graph or those things. I will try to relate all those things. Okay.
Why I'm asking is because, sir, if you like already I got the information that you will teach that converter. So if we
I will
read
teach.
little bit of, if we will go through that, so it will be very easy to understand while you teach in that way, sir.
Okay. I will explain all those things. I will explain. So DC converter also I will try to cover all those things. I will take personal doubts. So if you have any personal doubts, whatever question I'm explaining related to that, I will go to the theory part also. Okay. So if you ask any doubt during that time, I will explain the theory part also. So what is any see, so many lectures are available on YouTube. So many educators have posted their videos. You can refer there, but that are very long videos. NPTEL also you can refer. NPTEL like one IIT Delhi one madam is there.
So IIT Madras teacher is there, some name is there. So in
Okay.
NPTEL also they are only referring that.
Okay. For
IIT
power
Madras.
electronics, IISc Bangalore one professor very
Yes, sir,
senior
sorry, IISc Bangalore, sir. IISc
Professor
Bangalore.
L Umanand. So if you will
Yes,
refer
L.
his
Umanand,
power
yes.
electronics lecture, that will be very good.
Yes,
Like
sir.
for master's interview also, if you refer those videos, every like with simulation and LTS5 simulation will be there. So I will recommend you all of you should take that course. That if you want to do good in power electronics, so electrical I will suggest you one thing. Electrical like two domain people are going either in power electronics or in VLSI. Okay. So in this more job opportunities are there. So if you are in BTech or somewhere, so if you want to do good in interview for master's interview, Masters also two type of thing will be there. One MS will be there and one normal MTech will be there. But placement will be same in both. Even MS students are doing good. So MS you can get with more rank also. So I will suggest you to do some good power electronics course, NPTEL course, such that it will be better for you in interviews. Interview they will ask good quality questions. So if you will attend that NPTEL courses, just like Elumanan sir course, so it will be very beneficial for you. Your fundamental will be more clear. Okay.
And for like for machine and for power system, what is the how to grow in that way, sir, that field?
See, machine and power system, see, all are basically derived from network analysis only. Everywhere we
Right.
have to apply like complex power, S is equal to VI conjugate.
Yes, sir.
So if
Right.
you are good in network, okay,
Hmm.
slowly in power system, many domains are there like stability, fault. In fault, mainly KVL case will be there. So
Yes.
that syllabus is vast, but that is not a tough subject. Okay, slowly you can prepare your notes from some lectures.
No,
Okay,
sir, not in the notes. I am saying like to grow for career, sir.
okay,
I'm
you
talking
want
about that.
career in power system. Power system you want. See, power system is also okay, but now this is the time of the power electronics. Okay. See, electric vehicles, solar energy, everything is power electronics. So power
Hmm.
system also, if you are going there also now, like fax devices, those they are converting to those things. One part is protection, but that is also okay, but that is like outdated. You will not find more job opportunities there. So I will suggest you like you also should see like how like in other IITs people are getting job in which branch they are getting more job. So what my observation is like in electrical core, power electronics now it is trending till now. Power system little bit outdated. There also people are working in power electronics only. They are shifting to power electronics. Like power system they will do fact devices and all.
But the classical approach will be the same, no, sir. The concept, concept of the power system and all, that will be same, and
That will be
that is
same. That
benefited. I think that if anybody who has this quality,
okay.
so they
Anything
will be
you
definitely
okay.
benefited.
That concepts are required. Whatever you are learning in gate preparation.
Hmm.
See, if I am doing any microgrid analysis or something analysis, everywhere that power system concept I have to apply. Okay, like grid
Hmm.
connecting something. I'm connecting the inverter to the grid, so
Hmm.
that three phase analysis, apparent power analysis, everything will be useful only. Fundamentally, you are learning means it will be useful.
Hmm.
But recent trend is what I'm saying is recent trend is power electronics because electric vehicles and this solar energy, everything is going on. In coming 10 to 20 years, India power electronics, very more job opportunities will be there. So that's why I'm
Sir,
suggesting
is VLSI also part of that power electronics only?
VLSI, but that is large, low signal level. In power, we are doing at power signal level, like kilowatts. But okay, VLSI like small circuits, getting like
Hmm.
microchips or some processors, that kind of thing.
Hmm. Hmm.
Okay.
Sir, I have heard that in that domain also a lot of like
Lot of opportunities are there.
competitive market.
VLSI also good. So if you are interested in core electrical, then you can come to the power electronics. Otherwise,
Hmm.
if you are interested in electronics part, then you can switch to the VLSI based on interest. Power system also good. There also people are getting placement. But after coming to IIT, any branch, if you are doing MTech, means you'll learn some skill and you will get the placement. Branch will not matter.
Right, sir.
Okay.
Thank you, sir, for your valuable like your
Thank
insight
you.
of this.
Thank you all. So we'll meet on the next Monday, next class.
Thank you, sir.
Okay. Thank you all.
Sir, hello. One more thing.
Yes. Okay, you can ask.
Sir, can you please post the recording of
Recording will be
link?
posted on the NPTEL website. I'm sharing to the NPTEL team, so they will edit it and they will post it on the website.